In this question, you are asked to integrate 5x minus 2 by 3x square plus 2x plus 1. So this is of the form linear biquadratic. So till the previous example, you have integrals of the form 1 by quadratic. Now in this question, you have a linear in the numerator by quadratic in the denominator. So there is a very standard technique by which we can solve these questions. So the technique is something like this. We try to express the numerator in terms of the differentiation of the denominator. So what we do is integration of, first you have 3x square plus 2x plus 1 in the denominator. Now write the differentiation of this denominator. What is the differentiation of 3x square plus 2x plus 1? It is 6x plus 2, right? 6x plus 2 is the differentiation. Now once you write this, you start adjusting for the numerator. So in the numerator, first adjust the x term. You have a 5x here, but you have a 6x here. So what should you multiply this term to get a 5x? So obviously you need to multiply it with 5 by 6. So if you multiply it with 5 by 6, you have 5 by 6 into 6x is 5x. So x term is adjusted by multiplying this. Now, constant term is not adjusted till now. So if you do the multiplication, 5 into 2 by 6 is 5 by 3. 5 into 2 by 6 is 5 by 3. But here the constant is minus 2. So what we do is minus 2 is already there. You have added a 5 by 3 here. So you have to subtract a 5 by 3 also. So now effectively if you do the calculation, so 5 by 6 into 6x is 5x plus 5 by 3 minus 5 by 3 gets cancelled, minus 2 minus 2. So this is exactly the original expression. So what is the advantage that we have got by doing this? Now I'll separate these two. That is, this integral can be written as 5 by 6 times integral of 6x plus 2 by 3x square plus 2x plus 1 dx minus of 2 minus 5 by 3 is minus 6 minus 5 minus 11 by 3. So minus 11 by 3 is a constant times integration of 1 by 3x square plus 2x plus 1 dx. Now this has got separated into two parts. In one part you have the differentiation of denominator in the numerator. And the second part, this is 1 by quadratic, which we know how to do. So that is equal to 5 by 6 times. This is of the form f dash of x by f of x dx. So the answer is log mod 3x square plus 2x plus 1 log mod f of x minus 11 by 3 times. This has to be integrated in the general process by completion of squares. So integration of 1 by, so this can be written as a root 3x plus 1 by root 3 whole square. So root 3x plus 1 by root 3 whole square is 3x square. So what happens to the 2ab term? 2 into root 3x into 1 by root 3. That becomes 2x. And you have an extra 1 by 3 here, but you need a 1. So you add a 2 by 3. So 1 by 3 plus 2 by 3 is 1. And 2 by 3 can be written as root 2 by 3 whole square. Now these are the form 1 by a square plus x square dx. So the formula is 1 by a tan inverse x by a. So this has already been done. So minus 11 by 3 times tan inverse of, in the place of x you have root 3x plus 1 by root 3 divided by a is root 2 by 3, and you have a 1 by a in the formula. So into 1 by root 2 by root 3, right? So 1 by a, 1 by root 2 by root 3 tan inverse of x by a, but in the place of x you have root 3x plus 1 by root 3. X is being multiplied by root 3. So you need to divide it with an extra root 3. So these two gets cancelled. So root 2 gets multiplied with 3. So this term will be minus 11 by 3 root 2 tan inverse of, if you take the LCM, 3x plus 1 by root 2 plus c, and you have an extra this term here, 5 by 6 times log mod 3x square plus 2x plus 1 minus 11 by 3 root 2 this plus c is the integral.